So right, it had arc. Was it arc flash hazard analysis? Arc flash hazard analysis, right? That was the main heading, and then underneath that you had the two, right? You had the HRC, right? And then the incident energy was your other choice. Just so that you know that you can get this information can come from one of those two methods, right? For the most part, there was a bunch of other methods in there as well, but those are the main two. And I don't know if you guys, what else do you have that you found interesting in this chapter in general? Is there anything interesting? In chapter 8? There's a lot of calculations in there. We'll never be doing those, and there's none of those on the test. I know you were hoping for that one, huh?
I was. Yeah, I was.
Because you guys are getting real good at the math after the last stuff we did. But no, you're not going to get those in the text. Yeah, they spent a lot of time on that. All right, so you got those two methods down we talked about, and there's a couple questions on that. And it tells us that the arc hazard category method is considered by many to be the easiest method to use, but its application doesn't require determining that the conditions of use have been met. So there's a concern that if you use that HRC method, that you're not going to get accurate information to determine your PPE. It's simpler because you just go to two tables, but did it clear in the cycles that it said it would? Is it really the task that you thought you were going to be doing? Is it really the equipment that it says? And is the short circuit current what you think it is? So these variables make it so that it's not very accurate when you're using it, and you may find yourself exposed to a greater risk than what you determined based on that table, because you think, oh, okay, it's going to clear in the cycles it says. Or what happens is people become negligent and they just assume it's going to work out and clear, and it doesn't necessarily, it's not under those standards. So we just go, oh, just get the table and do it. That's not the best way to do it. It's better to go to these labels that you guys found on the panels, that someone's actually done a study and determined what the risks are. So on page 146 of the text, it talks about, I was just looking kind of at the AC system there, and the arc flash boundary, AFB. And it's talking about the fact that HRC is the easiest method. Yes, I'll agree that it's the easiest method. And I've never heard anybody, engineers, the few I've worked with, like I guess 3 different ones, I've never heard them talk about these other ones that are mentioned in this chapter, this Ralph Lee IEEE paper, or these other ones that are on page 147 where it talked about, there's another one in here, the Doherty Neil Floyd paper. I've never heard that one. So if they're doing that, they just don't share it to our level that that's how they found out the incident energy that's there, or the information that they're putting on those labels. Down at that bottom of 146, it's talking about what I mentioned about the number 1 is the types, the tasks, the parameters, and the potential arc boundaries that you're working with. The concerns are the clearing time and the working distance on page 148. Those make a big difference to what you're going to be exposed to. And 149, they go into a little bit about the arc flash boundary and incident energy calculation method discussion. What's a lot in that they asked us to do with that as far as the homework sections. Then they went into some fuse stuff. They started into the calculation methods and tools. At the bottom of 149. So it's good to know that there's somebody doing these calculations, but again, you're not going to be asked to do all of this, the math here. They're going to get those values, and then your part's going to be to go find those charts like that, and they have simplified that. You're learning the stuff that's outdated. Unfortunately, the books can't keep up with the changes, so It's actually simpler because there's no more 0 anymore. There's no more 2 star anymore, so it just goes 1, 2, 3, 4, and that's it. They simplified it. I know that's kind of rare because usually it seems like things go from simple to more and more complex, but they actually did simplify it. I think that's good because the more complicated it is, the less likely we end up with the right PPE to wear. And that's certainly our point. I did a little comparison there in figure 8-6 on page 150. I'm not going to read it to you again. You read it last week. You guys remember? Tell me what is a volted short circuit current? Like how does what do you
connected? Phase thing.
Is it phase? Why would they call it volted?
It's volted.
Volted.
It's not just arcing, it's actually got physically.
You're physically attached, welded on.
Yeah. Right? So through this piece, right? Is a bolt. So that's bolted, right? So the test is to see how much current is going to go with the bolted. So on 152 they started to do all this math. I can't say I've ever calculated any of these. And they didn't ask us to do any of these. So just recognize the complexity of it and recognize there's a program that does all of this, right? The engineers don't really sit there and do all this. There's a program they buy. Plug in the values, they'll have it. Your involvement could be going out and measuring lengths of cable runs, because the further away you get from the transformer, reduces some of that, the values. And then going and getting all the breaker readings and the settings on them, like how quick do they trip. Go find the values on the short circuit current. And go find those values on the breakers. Look at transformers and sizes of transformers. Sizes of the wires that go between the parts. With that information, they can determine what the energy, how much energy is going to be at each of the points. So that's what I've seen. They'll ask for, when the studies are screwed up, it's screwed up because the lengths are wrong or the size of the wires are wrong, and they can be really skewed. There's panels that shouldn't be category 4 over at one of the sites I worked at that needs to be restudied. There's a material building down now, so I don't go on that, but those are some of the problems that came up. So that's probably your involvement in what's happening with that information, is they're going to be able to find these values out that make the labels. There's some different equations that they have for fuses and circuit breakers. I didn't highlight anything in there that really jumped out as interesting. I thought on 157 it was kind of interesting about an online calculator that people at Cooper Busman put out. I didn't check to see if it still works or not. I know under the new Nfpa 70E for 2015 that it wouldn't be probably calculating all of these parts the way they are here. There's not going to be they probably tweaked the program slightly, but I thought, this is kind of interesting. I mean, if you did walk up to something and you saw, the breakers are rated at 40 for fault current protection, that they won't blow up. I mean, you go and see what this calculates. We would never do that either, but it's interesting that, if you just were sitting there and wondering what is the values, you could actually plug it in and come up with some numbers. They give you information specifically about a fuse and what would happen with a particular fuse in comparison to a breaker. So I thought that's kind of interesting to know that is out there. I wouldn't expect that anyone would ever expect us to go ahead and do those values or plug those in. But it's interesting to know if you just had an interest, you could be walking along and plug that into your phone and see what comes up. There was a question that was down there at the page 159 about updating our fault hazard analysis. The last paragraph, one of the questions was about that. Anybody know what is the frequency? To redoing the arc flash hazard analysis.
Now 65 years.
That's right. It talks about review periodically, not to exceed 5 years. That's one of the questions that we looked at last week. There's down on the bottom of page 160, in the last paragraph under overcurrent protective device conditions of maintenance, the reliability of overcurrent protection devices can directly impact arc flash hazards. Poorly maintained overcurrent protection devices may take longer to clear or may not clear at all, resulting in higher arc flash incident energy. So if you're in a new installation, maybe not the Taqueria down the street, but you're probably not as concerned as far as if things are problematic as far as old. There's more details in this other one. I guess I can say it twice, it won't hurt to hear it. But the grease that came with a brand new breaker, we're not talking little tiny ones, but the bigger ones, that grease over time gets hard and dry and crusty. I'm sure you've taken something apart, that you open it up and the grease is just kind of flakes off in big pieces. It's definitely not liquid anymore. So that same stickiness or hardness is happening inside that breaker, and the mechanical parts aren't necessarily going to open like they should. So you need to be aware of that, and of course, if you're working at an older site, is it going to function right or not? If you're on, permanently stationed somewhere doing maintenance, it's important to make sure that those breakers are exercised. I don't think it's in this chapter, but I'll say it twice. I'll say it when we get to the other one. But if you have an opportunity to push the red trip button, and someone says to turn something off, how can you turn this off or it's off? They want it to be exercised or you have a chance. That button there is going to operate all the mechanical parts differently than if you just throw the handle. So the trip, push the trip button, it's usually red on the front. That's a better way to de-energize something because it makes all the mechanical parts work, and you can, you're going to help maintain it better if it's not just stuck always in the same position. It's getting exercised. There should be some other people, on the crew that are probably from Eaton or Emerson Reliability Services, one of the testing companies, and they'll be responsible for actually doing some injection into the breakers and seeing if they trip properly. They'll also exercise those breakers mechanically. So along with the cleaning that we're doing, there would be the cleaning that they're doing and making sure that some of those other mechanisms are functioning correctly. You guys, this was on page 161. This is one of the codes that you guys took some pictures of. It's in the upper right corner. It's also in the body of the text there. NEC 11016 talks about that arc flash hazard warning label. And that's the labels that now the manufacturers are putting on there. That just gives you a general warning. A couple of you have that picture of that specific label. So that's one of the ones that's on the panels. We already covered the 3 items: the arc flash boundary, the nominal system voltage, and at least one of the other items, which we talked about already from that second column of 161. That was pretty much the chapter. Did anybody have anything more on that chapter you guys want to talk about? Timothy? Dominic? Back in the back? No? Alright. Check my recording. See if stop this part.